Okay, this tutorial is for section 5.2, simplifying radical expressions with, expressions with radical exponents. If you look at page 152 of your textbook, there are the 10 properties there of exponents. Just to recall, when you have exponents, when you have an exponent with the same base that are being multiplied together, you add the exponents. When you have exponents with the same base that are being divided, you subtract the exponents of those. When you raise the power of an exponent to another exponent, you multiply those exponents. Anything to the power of 0 is equal to 1. And also, if you have a negative exponent, that's like for a fraction, it's like flipping a fraction over and taking a positive exponent. And all of those kinds of properties, which you can find on page 152. So as you're going through these examples in this tutorial, keep in mind all the properties that we're going to be using on page 152 of your text. So what we're going to do is we're going to do 4 examples here, hopefully, and we'll start with this one. So we have to look at simplifying this expression. So we have to look at, how do you simplify 1/8 to the power of 1/3? Well, that's like taking the cube root of 1/8. So what we can do there is take the cube root of 1 is 1, and the cube root of 8, well, 8 is 2 times 2 times 2, so that would just be 1/2. Again, here the cube root of 27 is 3, and the cube root, because 27 is 3 times 3 times 3, and the cube root of 125 is 5, because that's 5 times 5 times 5. So that would be 3/5. This one's a bit more tricky here. 2 times 16 to the power of 3/4. Well, that means we're taking the 4th root of 16 to the 3rd power. So we're going to have to do this one out a little longer. So that's 2 times the 4th root of 16 to the 3rd power. Well, 16 to the 3rd power, well, we have 16 being, if we look at it, 4 times 4 times 3 times. Okay, so we have those factors, and we have to simplify them down a little bit more to the prime factors. So we could say this is 2 times 4th root of, we have 1, 2, 3, 4, 5, 6 4, so that means we'd have 12 2's. Six there, 9, 12 2's. So we have to take them in groups of 4. Well, that would be 3 groups of 4 there. Okay, so that's how you simplify that one down. And anything to the power of 0 is 1. So if we're going to simplify this, this would be 1/2 minus 3/5. This would be 2 times, well, we have 3 groups of 3 2's coming out of there. 1, 2, 3, so that would be 2 times 2 times 2, which is 8, minus 1. So this would be 1/2 minus 3/5 plus 16 minus 1. So this would, we have to do a fraction thing here, common denominator. For this would be 10. So this would be 5/10 subtract 6/10 plus 15. So this would end up being negative 1/10 plus 15. So that would equal 14 and 9/10. So there's one example there. Okay, I'm going to flip over my page and continue with the next example. I think we won't get as difficult this time. Let's just do a simpler example with the use of numbers. So let's say we had 3. Hoping the pencil shows up. My pens are dying on me here. Well, that doesn't look too good. Let me try this one here. 3 to the power of 2/3 over let's say 9 to the negative 1/2. Okay. Okay, so when we're working this one out, we can simply, there's a couple properties we have to be aware of here. So we can just keep this one as 3 to the power of 2/3. And we have to break the base down to 3 to the power of something. Well, 9 is 3 to the power of 2. And then we keep that in brackets and take the negative half power of that. So now we know using the product property of the top is going to stay the same, 3 to the power of 2/3. And this will just be 2 times negative 1/2, which is actually 3 to the power of negative 1. And then when we divide out numbers with the same base and the exponents, we subtract the exponents. So this would be 3 to the power of 2/3 subtracting negative 1. So that would be like saying 3 to the power of 2/3 plus 1. And 1 is actually 3 over 3. So this would be 3 to the power of 5/3 in exponent form. Okay. Okay, we've got enough time here to do another example, so let's use some letters here. So if we have 4 to the power of 1/2, or sorry, 4x to the power of 1/2, a y to the power of negative 2/3, all over 3 to the power x to the power of negative 1/3 over, or so not over, y to the power of 3/5. So then we can see that we're going to be subtracting exponents between the bases that are common. So that would be the same as saying the number is 4 over 3, x would be 1/2, subtract negative 1/3. And that's in the power placement. And y would be negative 2/3 starting there, subtract 3/5. Because subtracting because of the division. So 4/3. So this would be like x to the power 1/2 plus 1/3, because this would change to a positive. So 1/2 plus 1/3 in the exponent. This would be y, and we can do common denominator there of 15. So this would be negative 10 over 15 minus, and this would, for 15 would be 9 over 15. Okay, so this would be 4/3, and this would be x to the power, and do common denominator, 3/6 plus 2/6. This would be y to the power of negative 19 over 15. And then this would simplify down, hopefully I'm doing that large enough, to 4/3 x to the power of 5/6 y to the power of negative 19 over 15. Just check the field of view, make sure we can see that one. And that would be some examples of simplifying using the properties of exponents. I think I'm going to, in my next tutorial, do a couple more examples yet, but I'm running out of time on this video.